November 1942. The North Atlantic is not merely an ocean, it is a freezing, turbulent graveyard that stretches 3,000 miles from the eastern seaboard of the United States to the beleaguered ports of Great Britain. On this particular night, the darkness is absolute, a heavy, suffocating blanket that hides both hunter and prey. The wind howls at 40 knots, whipping the icy black swells into foaming crests that crash over the bows of the merchant convoy steaming eastward. These ships are the lifeline of the Allied war effort, floating warehouses filled with aviation fuel, aluminum, wheat, tanks, and ammunition. Without them, the war in Europe ends in a German victory. But beneath the churning surface, deep in the silent, pressurized cold, the hunters are waiting. Inside the steel hull of a Type 7C U-boat, the air is thick with the smell of diesel oil, unwashed bodies, and stale cabbage. The crew moves with the practiced, terrifying silence of predators. They are listening. The hydrophones pick up the rhythmic thrumming of propellers above the slow, heavy heartbeat of a 10,000-ton cargo ship. The German captain, eyes pressed to the rubber cups of the periscope, sees a silhouette against the faint starlight. He speaks a series of numbers, coordinates, and angles. The torpedo tubes are flooded. A hiss of compressed air follows, and a metal cylinder, packed with high explosives, races through the water at 30 knots. Seconds later, the ocean erupts. A column of fire and water shoots 300 feet into the night sky. The sound arrives a moment later, a dull, sledgehammer thud that vibrates through the hulls of every other ship in the convoy. Another merchant vessel, carrying enough supplies to equip an infantry battalion, begins its final, agonizing descent to the abyssal plain. This scene was not an anomaly, it was a nightly ritual. In 1942, the Battle of the Atlantic was bleeding the Allies dry. The mathematics of the war were brutally simple, governed by a grim ledger kept in Berlin by Admiral Karl Dönitz, the commander of the U-boat fleet. His strategy was known as the Tonnage War, or Tonnigerschlacht. The logic of the Tonnage War was terrifyingly irrefutable. Germany did not need to defeat the Allied navies in a direct confrontation. They simply needed to sink merchant ships faster than the Allies could build them. If the rate of destruction exceeded the rate of production, the lifeline to Britain and the Soviet Union would be severed. Britain would starve, the Soviet war machine would run out of fuel, and the planned invasion of Europe would die before the first soldier stepped onto a French beach. For the first half of 1942, the math was winning. U-boats were sinking ships at a catastrophic rate, sometimes exceeding 700,000 tons in a single month. In Washington and London, admirals and logistical planners looked at the charts with growing despair. The red line of losses was climbing vertically, while the blue line of new ship construction remained flat. The Axis powers believed, with statistical certainty, that victory was inevitable because the industrial capacity to replace such massive losses simply did not exist. Shipbuilding was an ancient art, a slow, deliberate process of craftsmanship that took months, sometimes years, to complete. To build a 10,000-ton freighter in under 6 months was considered a remarkable feat. To do it faster was deemed physically impossible. But to understand the miracle that was about to occur on the American West Coast, one must first understand the desperate state of the Allied merchant marine in the dark days before Pearl Harbor. The standard cargo vessels of the era were complex machines, pieced together by skilled artisans who had spent decades mastering their trade. A single ship required hundreds of thousands of rivets, each one heated white-hot, tossed through the air, caught in a bucket, inserted into a hole, and hammered flat by a team of men. It was a labor-intensive, deafening, and slow choreography. A shipyard was a place of tradition, where changes were viewed with suspicion, and speed was often synonymous with sloppy workmanship. The United States Maritime Commission, however, knew that tradition would not defeat the U-boat. They needed a ship that could be built by unskilled labor, by farmers, shopkeepers, and housewives who had never seen the ocean, let alone a shipyard. They needed a design that prioritized function over form, quantity over quality, and speed over everything else. The answer came in the form of a design that was initially rejected by the US Navy as aesthetically repulsive and mechanically obsolete. It was based on a British design from the J.L. Thompson and Sons shipyard in Sunderland, England, the Dorrington Court. The American adaptation was designated the EC-2SC-1, but the world would come to know them as Liberty ships. They were ugly vessels, often described by President Franklin D. Roosevelt as dreadful-looking objects. Time magazine called them ugly ducklings. They were 441 feet long with a beam of 57 feet, powered by a triple expansion steam engine that was essentially 19th century technology. But they had one supreme virtue: they were simple. And in the hands of a visionary industrialist named Henry J. Point Kaiser, simplicity became a weapon more potent than any battleship. Henry Kaiser was not a shipbuilder. He was a construction magnate, a man who had built dams, paved roads, and erected bridges. He knew nothing about the maritime traditions of the East Coast, and he cared even less. When he looked at a ship, he didn't see a unique vessel with a soul. He saw a massive steel structure that needed to be assembled. He applied the logic of the automobile assembly line to the leviathans of the sea. If Ford could build a car in minutes by moving the car past the workers, Kaiser reasoned he could build a ship in days by moving pre-assembled sections to the slipway. This concept, prefabrication, was the key. Instead of building the ship piece by piece from the keel up on the launchway, a process that tied up the slipway for months, Kaiser's engineers would build massive sections of the ship elsewhere in the yard. The bow, the stern, the deckhouse, the midship sections all were constructed simultaneously in open lots, then lifted by gigantic cranes and welded together like a colossal three-dimensional jigsaw puzzle. The shift from riveting to welding was the second critical innovation. Riveting required physical strength and years of practice. Welding, while requiring skill, could be taught in a few weeks. It was lighter, used less steel, and most importantly, it was faster, much faster. Under Kaiser's direction, the quiet, methodical atmosphere of the traditional shipyard was replaced by a 24-hour industrial frenzy. Floodlights turned night into day. The air was permanently filled with the acrid blue smoke of welding flux and the blinding flash of electric arcs. Men and women, thousands of them, swarmed over the steel carcasses. This was the environment at the Richmond shipyards in California, a sprawling complex on the northeast shore of San Francisco Bay that would become ground zero for the greatest manufacturing feat in history. By the autumn of 1942, the Richmond yards were already breaking records. The average time to build a Liberty ship had dropped from 240 days to 100 days, then to 60. But this wasn't enough. The U-boats were still sinking them. Kaiser wanted to prove a point. He wanted to show the world, and specifically the Axis powers, that American industry was not just waking up, it was accelerating into a realm of productivity that defied the laws of conventional economics. He proposed a stunt, a demonstration of raw power that would crush the morale of the German High Command. He ordered his team at Richmond Shipyard No. 2 to build a Liberty ship in less than 5 days. The ship was to be named the SS Robert E. Peary, after the famous Arctic explorer. The date was set, the materials were staged, the workers were briefed. This was not just a job, it was a combat operation fought with torches and cranes. The clock began at 1 minute past midnight on Sunday, November 8, 1942. The keel laying is usually a ceremonial affair, but for the Peary, it was a tactical strike. As the second hand swept past the 12, the massive steel spine of the ship was lowered onto the keel blocks. There was no pause for speeches. Immediately, swarms of welders descended upon it. Within hours, the bottom shell plates were being fused together. By daylight on Sunday, the shipyard was a hive of orchestrated chaos. The double bottom, the ship's foundational cellar, was already taking shape. The speed was disorienting. To a casual observer, it looked like a time-lapse film played in real time. Giant sections of the hull, weighing tens of tons, swung through the air on the cables of the whirly cranes, guided by hand signals and whistles. As soon as a section touched the growing structure, it was tacked in place, and the welders moved in to seal the seam. By the end of the first day, the entire bottom structure was complete. The pace did not slacken as the sun went down. Under the glare of thousands of incandescent bulbs, the graveyard shift took over. They were building the heart of the ship now. Monday, November 9th, saw the erection of the bulkheads and the side shells. The ship was rising from the slipway like a creature emerging from the deep. The complexity of logistics required to make this happen is difficult to overstate. Thousands of distinct parts, pipes, valves, wires, pumps, vents, had to arrive at the exact right moment. If a pipe fitter was 5 minutes late, he delayed the electrician, who delayed the insulator, who delayed the painter. It was a symphony of supply chain management conducted at a sprint. On Tuesday, the third day, the massive triple-expansion steam engine was lowered into the hull. This engine, weighing 135 tons, was the ship's beating heart. In a traditional build, fitting the engine was a delicate, weeks-long process of alignment and shimming. On the Peary, it was dropped in, bolted down, and hooked up in hours. The boilers followed. Then came the upper decks. The workers were running on adrenaline and patriotism. They knew they were part of something historic. They wore buttons that read, "Dare to do it." The noise was deafening, a cacophony of grinding metal, shouting voices, clanking chains, and the hiss of compressed air. By Wednesday, November 11th, Armistice Day, the ship was physically a ship. The deckhouses, which had been pre-assembled on the ground complete with wiring, plumbing, and even furniture, were lifted in huge blocks and welded to the deck. The mast houses were attached. The funnel, the iconic smokestack that defined the silhouette of the steamship era, was hoisted into place. But the true marvel was in the details. While the heavy steel work was finishing on the outside, teams of electricians and joiners were inside, pulling miles of cable, installing light fixtures, and fitting out the cabins. Painters followed inches behind the welders, their brushes slapping grey marine paint onto steel that was often still warm to the touch. Thursday, November 12th. The final day. The pace reached a fever pitch. The rigging was strung. The lifeboats were secured. The final inspections were a blur of clipboards and nodding heads. At the bow, the name Robert E. Peary was painted in white letters. The scaffolding was stripped away, revealing the finished vessel. It stood high and proud on the slipway, a 10,000-ton testament to American will. At 3:30 in the afternoon, just 4 days, 15 hours, and 29 minutes after the keel was laid, the blocks were knocked away. A cheer erupted from the thousands of workers, families, and dignitaries gathered at the yard, a sound that rivaled the roar of the machinery. The champagne bottles smashed against the bow, and the SS Robert E. Peary slid stern first into the waters of San Francisco Bay. It was a moment of pure, unadulterated triumph. The band played, men threw their hats in the air, and tears streamed down faces masked with grime and sweat. They had done the impossible. They had built a trans-oceanic cargo ship in less time than it took to drive one from New York to Los Angeles. The news of the launch rippled out from Richmond, traveling across the telegraph wires to Washington, to London, and inevitably to Berlin. For the German High Command, the report was initially dismissed as propaganda. It had to be a lie. No nation could build a ship in 4 days. It was physically impossible. The German engineering mindset, which prided itself on precision and methodical process, simply could not compute the data. They assumed the Americans had launched a hollow shell, a prop to boost morale. But intelligence reports confirmed the reality. The Peary was not a prop. It was a fully functioning cargo ship. Days later, it was outfitting, and shortly after that, it was carrying supplies to the Pacific Theater. This realization struck the German Admiralty with the force of a physical blow. Admiral Dönitz, the architect of the tonnage war, was a man of cold logic. He lived by the slide rule and the tonnage charts. For years, he had assured Hitler that the U-boat campaign would strangle Britain because the Allies could never replace the lost shipping tonnage. The sinking rates were high, yes, but the construction rates were the variable that mattered most. The launch of the Robert E. Peary shattered the variable. It wasn't just about one ship built in 4 days. The Peary was a symbol of what the entire American industrial machine was doing. The average build time across all shipyards was plummeting. The United States was producing 3 ships a day. For every ship a U-boat sank, the Americans were launching 2 more. The math had flipped. The tonnage war was lost. The psychological impact on the Axis leadership was profound. They were fighting a war against an enemy that could regenerate its material strength almost instantly. It was like fighting a hydra: cut off one head and two grow back, clad in steel and carrying radar-guided artillery. The Japanese leadership, too, felt the tremor. Admiral Isoroku Yamamoto, who had warned against awakening the sleeping giant, saw his worst fears realized in the rivets and welds of the Liberty fleet. The Peary demonstrated that the United States could translate its vast natural resources into war material at a velocity that no authoritarian regime could match. However, the technical achievement of the Peary and her sister ships was not without its controversies and costs. In the rush to mass-produce these vessels, quality control was sometimes pushed to the limit. The extensive use of welding, a relatively new technology in shipbuilding, led to unforeseen metallurgical problems. The steel used in the Liberty ships was often high in sulfur and prone to becoming brittle in the frigid waters of the North Atlantic. In the early days, there were catastrophic failures. Ships actually cracked in half while sitting in calm harbors or navigating heavy seas. The SS Schenectady, another Kaiser-built ship, famously split down the middle and sank at the dock just hours after completion. These failures were seized upon by critics and enemy propagandists as proof of American incompetence. But the American engineers responded with the same speed they applied to construction. They analyzed the fractures, identified the stress points, and implemented solutions. They added crack arresters, steel straps riveted to the hull to stop a crack from propagating. They improved welding techniques and steel quality. They learned, adapted, and kept building. The failures were tragic, but they were viewed as the cost of doing business in a war for survival. The ships did not need to be perfect. They needed to be good enough, and they needed to be there now. The SS Robert E. Peary went on to serve in the Pacific and Atlantic theaters. She was not a glamorous ship. She had no heavy armor, no big guns, and she wallowed in heavy seas. Her crew lived in cramped quarters, sleeping on bunk beds stacked 3 high, constantly aware that a single torpedo could turn their floating home into a coffin. But she did her job. She carried locomotives to Russia, tanks to France, and grain to a starving Europe. She was part of the bridge of ships that spanned the oceans, a continuous conveyor belt of supplies that overwhelmed the Axis powers. The legacy of the Robert E. Peary extends far beyond the 4 days of her construction. She represents a turning point in the history of warfare and industry. Before this moment, war was often decided by the bravery of soldiers and the tactical genius of generals. But in the Second World War, and specifically in the example of the Liberty ships, victory was decided by logistics. It was decided by the man who could mine the ore, smelt the steel, roll the plate, and weld the hull faster than his enemy. It was a victory of systems, of management, and of the unglamorous, gritty determination of the American worker. When we look back at the launch of the Peary, we are seeing the birth of the modern industrial superpower. The techniques refined in the Richmond shipyard's modular construction, just-in-time delivery, standardized parts would become the blueprint for post-war manufacturing. They would build the cars, the skyscrapers, and the airplanes of the American century. But in November 1942, they were simply the means to an end. The German admirals who stared at the intelligence reports in 1942 realized something that terrified them more than any bomber raid. They realized that they were not just fighting an army, they were fighting an industrial avalanche. They could sink ships, they could bomb factories, they could kill men, but they could not stop the tide. The launch of the SS Robert E. Peary was the moment the Axis powers looked across the ocean and realized that the war was no longer winnable. The sleeping giant was not just awake, it was building a new world at record speed, and it was coming for them. The Peary survived the war, a veteran of the most dangerous shipping lanes in history. She was eventually scrapped in 1963, her steel recycled into the growing infrastructure of a peaceful world, but her spirit remains. It is found in the belief that with enough will, enough organization, and enough shared purpose, the impossible is merely an engineering challenge waiting to be solved. The 4 days, 15 hours, and 29 minutes it took to build her remain a benchmark of human productivity, a reminder of what can be achieved when a nation unites its hands and its heart in a singular, desperate, and magnificent cause. To fully appreciate the scale of this endeavor, we must step back and visualize the global chessboard as it stood in late 1942. While the welders at Richmond were fusing steel, the German Sixth Army was grinding into the ruins of Stalingrad. In the Pacific, Marines were bleeding on the jungle slopes of Guadalcanal. The British Eighth Army was engaging Rommel in the sands of El Alamein. Every one of these battles hung on a razor's edge, and every one of them depended entirely on the flow of supplies. A tank in Stalingrad was useless without fuel. A Marine on Guadalcanal was dead without ammunition. The Liberty ship was the common denominator that linked these disparate theatres of war. It was the humble, rusted container that carried the fuel of victory. The genius of the Liberty ship program was that it turned the complexity of shipbuilding into a decentralized national effort. Parts for the Peary and her sisters were not just made in shipyards. The winches came from Arkansas, the rudders were cast in Ohio, the clocks were made in Connecticut, the life rafts came from West Virginia. The entire continental United States was converted into a single, massive factory floor. A woman assembling a valve in a factory in Denver might never see the ocean, but the work of her hands would eventually find itself floating in the Persian Gulf or the Barents Sea. This was total war in its most absolute economic sense. Henry Kaiser, the man who orchestrated this symphony, became a folk hero. He was the face of American can-do optimism. He offered health insurance to his workers, a revolutionary concept at the time, because he knew that a healthy worker was a productive worker. He built housing, schools, and daycares near the shipyards so that women could work the shifts while their children were looked after. This social engineering was just as important as the mechanical engineering. It expanded the workforce by millions, tapping into a reservoir of labor that the Axis powers, with their rigid social structures, largely ignored. Germany used slave labor, which was inefficient and prone to sabotage. America used free labor, motivated by patriotism and high wages, and the difference in output was staggering. As the war dragged on, the Liberty ships evolved. They were modified into troop transports, hospital ships, floating repair shops, and even tanker variants. They were the universal platform of the war, and as the U-boat threat began to recede, driven under by Allied technological advances in radar, sonar, and air power, the flood of Liberty ships became a tsunami. By 1944, the Allies had so much shipping capacity that they could afford to use these ships as artificial breakwaters during the D-Day invasion of Normandy. They were deliberately scuttled to form gooseberry harbours, creating calm water for the landing craft. It was the ultimate display of material abundance, using 10,000-ton ships as disposable building blocks. But let us return to the deck of the Robert E. Peary in the moments after her launch. As the tugboats nudged her toward the fitting-out dock, the workers at Slipway No. 2 were already laying the keel for the next ship. There was no pause, no holiday. The record had been set, but the war was not over. The dust from the Peary's slide had barely settled before the cranes were swinging new steel into place. This relentless momentum is what truly broke the spirit of the enemy. It was the realization that for every ship they destroyed, the Americans would simply build another, faster and better. It was a war of attrition where one side had infinite resources and the other had a ticking clock. The story of the SS Robert E. Peary is also a story of the democratization of technology. Before the war, complex machinery was the domain of the elite engineer and the master craftsman. The Liberty ship program proved that complex technology could be simplified, standardized, and mastered by the average citizen. It foreshadowed the consumer revolution of the post-war era, where automobiles, appliances, and eventually electronics would be mass-produced for a global market. The lessons learned in the frantic days of 1942 laid the groundwork for the economic boom of the 1950s and 60s. The men and women who learned to weld on the hulls of Liberty ships went on to build the pipelines, the skyscrapers, and the bridges of modern America. In the final analysis, the Robert E. Peary was more than just a ship. She was a message sent in steel and steam to the fascists of Europe and the militarists of Japan. The message was simple. You cannot win. You have awakened a force that is beyond your comprehension. You are fighting against the geometry of mass production, the chemistry of high-speed welding, and the sociology of a free people united in a common cause. And as the Peary sailed under the Golden Gate Bridge, heading for the open Pacific, she carried that message to the world. Today, only a handful of Liberty ships remain as floating museums. The SS Jeremiah O'Brien in San Francisco and the SS John W. Brown in Baltimore are the last survivors of a fleet that once numbered over 2,700. Walking their decks today, one is struck by the utilitarian starkness of the design. There is no wood trim, no brass polishing, no comfort. Every rivet, every weld, every bulkhead screams of urgency. They feel temporary, built for a specific moment in time when the world was on fire. And yet, they have outlasted the empire they were built to destroy. They have outlasted the men who built them and the crews who sailed them. They stand as silent memorials to the 4 days in November when American workers did the impossible and changed the course of history. The German admirals were right to give up hope. When they saw the Robert E. Peary, they saw the future, and they saw that there was no place in it for them. The mathematical certainty of their defeat was written on the hull of a ship built in 4 days. It was the triumph of the assembly line over the ideology of the master race. It was the victory of the welder over the warrior, and it remains, to this day, one of the greatest industrial achievements in the history of mankind. As we reflect on this monumental event, we must consider the human cost woven into the steel. The shipyard workers paid a price for their speed. Accidents were common. People fell from scaffolding, were crushed by swinging steel, or were blinded by welding arcs. The pressure was relentless. Fatigue was a constant companion, but they kept working. They understood in a visceral way that their sweat was saving blood on the battlefield. Every hour saved in construction meant supplies reached the front an hour earlier. Every extra ship launched meant a crew of sailors might survive a sinking because there was another ship nearby to rescue them. The connection between the home front and the battlefront was absolute. In the grand tapestry of World War II, the battles of Midway, Stalingrad, and D-Day often dominate the narrative. We are drawn to the drama of combat, the clash of armies, the heroism of the individual soldier. But the war was won in places like Richmond, California. It was won by people whose names we will never know, wearing hard hats instead of helmets, wielding torches instead of rifles. The SS Robert E. Peary is their monument. It is a testament to the fact that when civilization was threatened by the darkest of evils, ordinary people achieved extraordinary things through the sheer force of collective will. The water of the North Atlantic is still cold, and the wind still howls over the grey swells. The U-boats are long gone, rusting on the ocean floor or scrapped in forgotten yards. But the shipping lanes they once terrorized are now the arteries of global commerce, filled with massive container ships that dwarf the Liberty ships of the past. Yet, none of these modern leviathans carry the same weight of history as the Robert E. Peary. She was a small ship by modern standards, ugly and slow, but for 4 days in 1942, she was the most important ship in the world. She broke the blockade, she broke the will of the enemy, and she proved that even in the darkest of times, human ingenuity and determination can forge a path to victory. The echo of those chipping hammers and the hiss of those welding torches still resonate in the structure of our modern world. The capacity to organize, to produce, and to innovate under pressure is the enduring legacy of the Liberty Ship program. It is a reminder that the impossible is often just a lack of imagination and effort. When the world needed a miracle, American workers built one, plate by plate, weld by weld, in 4 days, 15 hours, and 29 minutes. And in doing so, they saved the world. To truly grasp the magnitude of the Peary achievement, we must delve deeper into the abyss of the year 1942, a year that historians often cite as the nadir of the Allied cause. The optimism of the post-war era often obscures the terrifying reality of those months. The Axis powers were not merely winning, they were dominant. In the Pacific, the Imperial Japanese Navy had swept across Southeast Asia, capturing the rubber plantations of Malaya and the oil fields of the Dutch East Indies. In North Africa, the Afrika Korps was threatening the Suez Canal, the jugular vein of the British Empire. And in the Atlantic, the U-boat crews referred to this period as the Second Happy Time. They were operating with near impunity off the American coast, silhouetted against the lights of coastal cities that had not yet implemented blackouts. Tourists on beaches in Florida and New Jersey could sometimes see burning tankers on the horizon. The war was not over there. It was washing up on the shoreline in the form of oil, debris, and bodies. The strategic situation was dire because the Allies were fighting a global war on the end of a 10,000-mile supply chain. The logistics required to support a single soldier in the field were staggering. He needed food, uniform, boots, rifle, ammunition, helmet, gas mask, medical kit, shelter half, and the transport to get him there. Multiply that by millions of men. Then add the tanks, each weighing 30 tons, requiring spare parts, tracks, engines, and thousands of gallons of fuel. Add the aircraft, the artillery, the trucks, the jeeps. All of this material had to be manufactured in the United States and transported across oceans infested with submarines designed specifically to stop it. The Liberty ship was the only solution to this logistical nightmare. It was the boxcar of the ocean. The design of the Liberty ship, while simple, was a marvel of compromise and engineering pragmatism. The decision to use a steam engine instead of a diesel engine or a steam turbine is a perfect example of this wartime logic. The United States Navy wanted turbines for their speed and efficiency, but the companies capable of building large reduction gears, General Electric and Westinghouse, were already at maximum capacity building turbines for warships. There was no capacity left for merchant ships. So, the Maritime Commission dusted off designs for triple expansion reciprocating steam engines. These were towering, cast-iron beasts, standing 2 stories tall. They were heavy, inefficient, and vibrated terribly. But they had crucial advantages. They were reliable, they could be repaired by any mechanic with a wrench and a sledgehammer, and most importantly, they could be built by foundries all over the country that made steam shovels or mining equipment. They didn't require the high-precision machining of a turbine. This decision to use obsolete technology was a stroke of strategic genius. It allowed the United States to tap into a vast, underutilized industrial base. Let us look closer at the construction of these engines, for it mirrors the construction of the ship itself. The cylinders were cast in sand molds. The pistons were the size of dining tables. When steam entered the high-pressure cylinder, it pushed the piston down, turning the massive crankshaft. The steam then exhausted into the medium-pressure cylinder, and finally into the low-pressure cylinder, squeezing every ounce of energy from the coal or oil that heated the water. The rhythmic thump-thump-thump of a Liberty ship engine was the heartbeat of the convoy. It was a sound that sailors learned to sleep by, a comforting reassurance that they were still moving, still alive. But the engine was just one piece of the puzzle. The hull itself was a battleground of engineering innovation. We have mentioned welding, but the specifics of the welding process at the Richmond shipyards deserve closer inspection. Kaiser introduced a technology known as union melt, an automated submerged arc welding process. In traditional hand welding, a worker holds an electrode and manually maintains the arc. It is slow and subject to human error. With union melt, a machine moved along a track laid over the seam. It fed a continuous wire electrode into a mound of granular flux. The arc was buried beneath the flux, shielding the molten metal from the air without the need for a gas shield. This allowed for single-pass welds on thick steel plates at speeds that were previously unimaginable. A seam that would take a skilled manual welder hours to complete could be done by a union melt machine in minutes. And because it was a machine, the weld was uniform, deep and strong provided the steel chemistry was correct. This automation was part of the reason why Kaiser could employ so many unskilled workers. You didn't need to be a master welder to operate a union melt machine. You just needed to know how to set it up and watch the gauges. This opened the doors to women, the famous Rosie the Riveters, though in the Richmond yards, they were often Wendy the Welders. Women from all walks of life flooded into the shipyards. Former waitresses, teachers, and farm girls donned leathers and welding helmets. They proved to be exceptional at the work. Their dexterity and attention to detail often surpassed that of their male counterparts. The social transformation within the shipyard was as radical as the industrial one. For the first time, women and minorities were earning high union wages, working side by side with white men. It was a melting pot forged in the heat of the war effort. The sheer scale of the Richmond shipyards was overwhelming. There were actually 4 shipyards in the complex, employing over 90,000 people at its peak. It was a city unto itself. The logistical infrastructure to feed and transport this army of workers was massive. A dedicated railway system brought steel from the mills in the east. Buses shuttled workers from temporary housing projects that had sprung up overnight. The cafeteria at the shipyard served tens of thousands of meals a day. It was a 24/7 operation that never slept. At night, the glow from the shipyards could be seen for miles, a beacon of industry that signaled the unrelenting nature of the American war machine. Now, consider the specific timeline of the Robert E. Peary again, but this time through the eyes of the foremen and supervisors who had to orchestrate this ballet. The planning for the record attempt began weeks in advance. Every piece of steel was color-coded. Every sub-assembly was measured and remeasured to ensure it would fit perfectly. The margin for error was 0. If a section was lowered and didn't fit, there was no time to send it back for rework. It had to be cut and welded in place, on the fly. The foremen carried stopwatches. They analyzed the movement of workers like sports coaches analyzing game tape. They eliminated wasted motion. If a worker had to walk 50 feet to get a tool, that was time lost. Tool cribs were moved closer. Water stations were positioned strategically. It was the application of scientific management, the theories of Frederick Winslow Taylor, taken to their absolute extreme. During the construction of the Peary, the weather held, which was a small mercy. Rain would have slowed the welding and made the steel slippery and dangerous. But the danger was always there. In the rush, safety protocols were often secondary to speed. Cranes swung heavy loads over the heads of workers. Electric cables snaked everywhere, creating tripping hazards. The air was thick with fumes. Flash burn. A painful condition caused by looking at the welding arc without protection was common. It felt like having sand in your eyes. Workers would go to the infirmary, get their eyes treated, and go right back to the line. The motivation was not just the paycheck. It was the newsreels playing in the local theaters showing the devastation of the war. Everyone had a brother, a son, or a husband overseas. Building the Peary fast wasn't just a stunt. It was a way to bring them home sooner. The rivalry between the Kaiser shipyards added another layer of intensity. The Oregon Shipbuilding Corporation in Portland, also owned by Kaiser, was the main rival of the Richmond yards. They traded records back and forth. When Oregon launched the Joseph N. Teal in 10 days, they sent a telegram to Richmond rubbing it in. The workers at Richmond took it personally. The Peary was their retort. It was a point of pride. The competition drove innovation. If Oregon figured out a better way to pre-assemble a bulkhead, Richmond would steal the idea and improve it. This internal competition, fostered by Kaiser, drove the man-hours per ship down relentlessly. In 1941, it took over 1 million man-hours to build a Liberty ship. By 1944, it was down to less than 500,000. The cost of building the ships dropped by half, saving the taxpayers billions of dollars. The launch of the Peary also highlighted the role of the expediters. These were the men and women whose job was to chase down parts. If a shipment of valves was stuck in a rail yard in Chicago, the expediter was on the phone, screaming, cajoling, and bribing to get it moving. They were the unsung heroes of the supply chain. For the Peary, the expediters ensured that every bolt and gasket was on site before the keel was laid. They created a kit for the ship, so that workers never had to wait for material. This concept of kitting is standard in manufacturing today, but in 1942, it was cutting-edge logistics. We must also look at the strategic implications of the bridge of ships on the European front. By 1943 and 44, the sheer volume of American supplies was altering the tactical reality of the battlefield. German soldiers were often astounded by the abundance of Allied material. They would capture American positions and find fresh chocolate, cigarettes, dry socks, and endless ammunition. In contrast, the German supply lines were being strangled. They were running out of fuel. Their trucks were breaking down. They were using horses to pull artillery. The disparity was demoralizing. A German soldier might destroy 5 Sherman tanks, but the next day, 6 more would appear. This material superiority, delivered by the Liberty ships, allowed the Allies to make mistakes and still win. It allowed them to overwhelm the superior tactical skills of the Wehrmacht with blunt force trauma. The Peary and her sisters delivered the sledgehammer. Let us describe the experience of sailing on a Liberty ship like the Peary. It was not a comfortable life. The ship was lively in a seaway. It rolled and pitched heavily. The hull would groan and creak as it flexed in the waves. In the North Atlantic winter, ice would form inches thick on the rigging, making the ship top-heavy and dangerous. The crews, often a mix of veteran merchant mariners and young recruits, lived in a state of constant tension. The convoys moved at the speed of the slowest ship, usually around 8 or 9 knots. This made them sitting ducks for U-boats. The wolf pack tactic involved multiple submarines attacking a convoy at night on the surface, where their speed was greater than submerged. The sky would light up with star shells and burning ships. The Peary was armed, usually with a localized stern gun and some anti-aircraft guns, but these were defensive weapons. The best defense was the convoy escorts, the destroyers and corvettes, and the sheer number of targets. It was a lottery of death. Yet, despite the danger, the merchant marine had the highest casualty rate of any service branch in the war, proportionally. 1 in 26 mariners died. They were civilians, volunteers who kept sailing despite the odds. The construction of the Peary in 4 days was a tribute to their courage. It was the industrial workforce telling the mariners, "We have your back. We will build them faster than they can sink them." This bond between the builder and the sailor was palpable. The Peary's construction also marked a shift in the global perception of the United States. Before the war, America was seen as an isolationist nation, rich but unwilling to engage with the world. The industrial explosion of the war changed that forever. The world saw that America could project power anywhere on the globe. The Liberty ship was the vehicle of that projection. It carried not just goods, but American culture, food, and ideas to every port it touched. It laid the foundation for the post-war global order, where the United States Navy guaranteed the freedom of the seas for trade. There is an interesting technical footnote regarding the Peary and the Liberty ships: the propeller. The original design had a flaw where the propeller shaft would vibrate harmonically at certain speeds, causing it to snap. This was a terrifying failure that would leave a ship drifting helplessly. The solution was found not by redesigning the entire engine, but by slightly changing the shape and weight of the propeller to alter its resonant frequency. This fix was retrofitted to the fleet. It is another example of the pragmatic, problem-solving approach that characterized the program. They didn't look for the perfect theoretical solution. They looked for the one that worked and could be implemented immediately. The legacy of the Peary also reaches into the realm of environmental history, though in a darker way. The rush to build ships and the war itself caused massive pollution. The shipyards dumped waste into the bays. The ships burned heavy bunker fuel that polluted the air. The wrecks on the ocean floor are still leaking oil today. This is the forgotten cost of the miracle. But in 1942, the environment was a secondary concern to survival. The existential threat of fascism outweighed the long-term damage to the ecosystem. It is a complex ethical balance that historians and environmentalists still debate. As we near the end of this narrative, we should revisit the German Admirals' perspective one last time. Imagine the scene in the U-boat headquarters in occupied France. The walls are covered with maps of the Atlantic, pinned with the locations of sinkings. For months, the mood has been jubilant. Champagne has flowed. Medals have been awarded. But then, the reports start changing. The convoys are getting larger, the air cover is denser, and the intelligence officers bring in the news clippings and the intercepts about the Robert E. Peary. The realization is a slow, creeping dread. It is the realization that their enemy is not playing by the same rules. Germany is fighting a war of knights and warriors. America is fighting a war of corporations and assembly lines. The romanticism of the grey wolves of the U-boat fleet cannot stand against the cold, hard steel of mass production. The launch of the Peary was the death knell of the romantic view of war. It signaled the triumph of the machine age. The Robert E. Peary was eventually renamed and sold after the war, disappearing into the anonymity of the global merchant fleet. But her name remains etched in the record books. 4 days, 15 hours, 29 minutes. It is a record that has never been beaten for a ship of that size and complexity. In the modern era of computer-aided design and robotics, we still cannot match the speed of those desperate days in 1942. Why? Because we lack the singular existential urgency that drove the workers of Richmond. We have regulations, safety standards, and economic constraints that did not exist in the same way during total war. The Peary is a reminder of what human beings are capable of when the constraints are removed and the motivation is absolute survival. In conclusion, the story of the SS Robert E. Peary is the story of the turning point of the 20th century. It is the moment when the industrial potential of the United States was fully unleashed, creating a momentum that would crush the Axis powers and shape the modern world. It is a story of steel, sweat, and salt water. It is a story of welders, riveters, sailors, and engineers. But mostly, it is a story of hope. The hope that when the night is darkest and the odds are stacked against freedom, the human spirit can rise to the occasion and build a miracle even if it takes just 4 days. The shipyard at Richmond is quiet now. The cranes are gone or stand as rusted sentinels. The slipways are empty, but if you stand on the shore of the bay, where the Peary first tasted the water, you can almost hear the echo of the whistle, the roar of the crowd, and the splash of the hull hitting the tide. It is the sound of victory. It is the sound of a nation that refused to lose, and it is a sound that history will never forget.